Good morning again, guys. This is Mike, again coming at you with a video on Foundations of Math 2. In the previous video, we talked about using permutations and or combinations to determine probabilities of single events. In this video, we are going to talk about finding probabilities of two or more events, and some rules that we use to determine the probability of some combination of two or more events happening. So everything we've done up until this point was finding a probability for a single particular event, but as I said, now we're getting into more than one event happening here. And the calculation can be pretty straightforward and pretty easy, or it can be slightly less easy. And which one it is depends on whether or not the events involved are mutually exclusive. That is the key phrase, the key two-word phrase right there, mutually exclusive. So what does it mean for two events to be mutually exclusive? Two or more events. It can be 3 or 4 or 5, but for the most part, we're just going to focus on two. Two events are mutually exclusive if they have no outcomes in common. That is to say, they can't both happen at the same time. So just a little warm up here, just so we can identify whether or not two given events are mutually exclusive. Picking a 5 and picking a 9 from a regular 52 card deck. Are these two events mutually exclusive? That is, can you possibly in one pick, can you pick a 5 and a 9 at the same time? No, 5 and 9 are not the same number. They don't have the same value. So you can't pick a 5 and pick a 9 in the same single pick. Obviously, if you have two separate picks, then you could pick a 5 in one and a 9 in the other. But we're talking just one single pick of a card from a regular 52 card deck. You can't pick both a 5 and a 9 at the same time. So yes, these two events are mutually exclusive. How about picking a black card or picking a face card from a regular 52 card deck? Is it possible to, in a single draw, pick a card that is both black and is also a face card? Yes, that is possible. It is possible to, in a single draw, pick a card that is both a face card and black. You have the Jack of Clubs, Queen of Clubs, King of Clubs, Jack of Spades, Queen of Spades, and King of Spades. So no, these events are not mutually exclusive. And third one, selecting an audience member that is male or is not a fan of dogs. In a standard group of people, if you chose someone in the audience, is it possible to pick someone that is male and is not a fan of dogs? Yes, that is certainly very, very possible. Maybe based on who's meeting, maybe you won't necessarily get that, but just in general, overall, these two events, picking a male and picking someone that is not a fan of dogs, those are not mutually exclusive events. So that's just a little bit of warm-up, just a little bit of practice to help us figure out whether or not two events are mutually exclusive or not. So now on to calculating those probabilities. If the two events, A and B, are mutually exclusive, then finding your probability is really, really nice. Then the probability of A or B happening is simply the sum of the probability that A happens and the probability that B happens. Very simple, very straightforward. P of A or B, P of A plus P of B. If the two events are not mutually exclusive, then it's not that much worse. There's this one little thing that we have to also keep in mind, and we have to subtract that piece out. If the two events are not mutually exclusive, then P of A or B equals P of A plus P of B minus P of A and B, minus the probability of both things happening at the same time. And to give you some explanation as to why we have that piece in there without going into a ton of detail, probability of A or B happening, we only want to know what's the probability of each thing happening on its own, and we also want to know the probability of it happening once. If the events are not mutually exclusive, then P of A and P of B, if you just take those sums, then there's some part of it that you're actually counting twice. And what you're counting twice is where A and B happen simultaneously. So we don't want to be counting something twice, we only want to be counting it once. So the way we go from counting something twice to counting that same thing only once is we subtract out one of the things that we were counting twice. And since we said what we're counting more than once is that A and B happening, that's why we subtract that P of A and B. So our sample problems here, find the probability of the first scenario in the first example. Namely, we're going to find the probability of picking a 5 or picking a 9 from a regular 52 card deck. So the probability of picking a 5 or a 9. Well, we said that these were mutually exclusive events. So by our formula here for finding the probability of mutually exclusive events, the probability of picking a 5 or a 9 is the probability of picking a 5 plus the probability of picking a 9. Question is, what's the probability of picking a 5 from a standard 52 card deck? Well, how many 5s are there in a standard 52 card deck? There's 4 of them out of the possible 52 cards. And then the probability of picking a 9. Again, there are 4 9s out of a possible 52 cards. So 4 over 52 plus 4 over 52 is 8 over 52, or 4 over 26, or 2 over 13. Now, some of you may be thinking, okay, picking a 5, I can see that being 4 over 52, but then maybe some of you were thinking, okay, you've picked the 5 out, and then the probability of picking the 9, well, there's 4 9s, but then wouldn't there only be 51 cards because you picked that 5 out? That's not what's happening here. We aren't saying that we're not putting that card that we picked. We're not saying that we aren't putting that 5 back. These are two completely separate things going on here. Just, you have your deck, you pick your 5, you put it back, you then pick your 9. Two separate things in both instances, 52 possible cards to pick from. Let's find the probability of the second scenario in the first example. That is the probability of picking a black card or picking a face card. So probability of picking a black card or a face card. Okay, we said that these are not mutually exclusive events. There are ways in which we can pick both simultaneously. So this probability is going to be the probability of picking a black card plus the probability of picking a face card, and then minus the probability of picking a black card and a face card. Here. Again, P of A plus P of B minus P of A and B. So let's figure out each of these three probabilities individually, and then we'll do the appropriate sum and or difference. So what's the probability of picking a black card from a standard 52 card deck? Well, there's 26 red cards and there's 26 black cards. So 26 black cards out of a possible 52. Plus, what's the probability of picking a face card? Well, face cards are the jacks, the queens, and the kings. There are 3 face cards per suit, and there's 4 suits. So there's 12 face cards in the standard 52 card deck. And now how many, or what's the probability, I should say, of picking a face card that is a black card as well? Well, as we mentioned earlier on in this video, we have the Jack, Queen, and King of Clubs, as well as the Jack, Queen, and King of Spades. So we have 6 cards that are face cards and black cards out of the possible 52. So now let's take the difference or sum of these fractions. The bottoms are all the same, so we just add or subtract the tops. 26 plus 12 is 38, minus 6 is 32 divided by 52. And that gives me 16 over 26, or 8 over 13. So that's the probability of picking a black card or a face card. So we can see how this formula here got used, how that extra piece comes into it. The third example here, you roll 2 fair 4-sided dice. Find the probability of rolling doubles or getting a sum of 4. Now, first thing you want to do is identify, are these 2 events, rolling doubles or rolling a sum of 4, are those events mutually exclusive? two fair four-sided dice are being rolled, each side numbered 1 through 4. Probability of rolling a doubles or rolling a sum of 4. Is there any possible way that with my rolls of these two fair four-sided dice, can I get doubles and have their sum be 4? Yes, that is possible. If each of my dice are 2, then those are doubles because they're the same, and add those 2 up and you get 4. So we do have to note that these are not mutually exclusive, or not ME for short. So we are going to have to use this formula here that we used for our previous problem. We are going to have to do P of A plus P of B minus P of A and B. But now to get these probabilities of these things happening, what are all the possible outcomes we can have? This is where we would appeal to something from a previous video where maybe you sketch out a tree diagram or maybe you do a table or something like that to figure out what are all the possible outcomes we can have for rolling these two fair four-sided dice, and then we can use that table to determine the probabilities of these pieces that we need. So take some time on your own, do a tree diagram, do a table, whatever you want to do. Figure out the sample space for this scenario that we are in. And once you've done that, press play, and we will finish off this problem. All right, so here is my table with all of the possible outcomes that we can have for rolling these two fair four-sided dice. I simply recorded my possible outcomes as the roll that you can get from rolling the first die and then followed by the roll of the second die. So the probability of rolling doubles or getting a sum of 4 for the two dice is going to equal probability of doubles plus the probability of a sum of 4 minus the probability of doubles and sum being 4. So looking at our table here, what's the probability that we can roll doubles here? Well, here's a double, here's a double, here's a double, and there's a double. So there's 4 doubles out of how many different possible outcomes? 4, 8, 12, 16. All right, what's the sum, or what's the probability that the sum of the numbers that you get is 4? Well, we have 3 plus 1 gives me 4, 2 plus 2 gives me 4, and then 3 and then 1 gives me 4. These are not the same outcome. Here it's 3 on the first roll and 1 on the second roll. Here it's 1 on the first roll and 3 on the second roll. So 3 outcomes that give me a sum of 4, again, out of 16 possible outcomes in the entire sample space. And now minus the probability that you get that what you rolled in your 2 rolls is a double and the sum is 4. Well, there's only one possibility there. It's 2, 2. That's the only way we can get a double and have the sum of the 2 numbers being 4. So that's going to be 1 out of 16, or 1 over 16, I should say. So add or subtract these guys. We get 6 over 16, or 3 over 8. And that is the probability that we would roll doubles or get a sum of 4 in our two rules. So these two formulas right here that we use to figure out the probability of two events happening, these are known as the addition rules for probability. And these were formulas that we use to figure out the probability of A happening or B happening. In the next video, we are going to talk about formulas that we can use to figure out the probability of A happening and B happening. So if you guys have any questions or comments, please be sure to reach out to me. Emails, texts, phone calls, bat signals, signal flares, whatever you have to do. Until the next video, take it easy, guys.